Namaskar students. So I think I have only 8 minutes for this memory card. So remember what we learnt last time. So location of Fermi energy in the band structure for intrinsic means pure semiconductor is exactly at the middle of the energy band gap. This is what we have learnt last time, yesterday, whatever. So today we will be thinking what happens to extrinsic semiconductor. So position of Fermi level, and mainly for extrinsic semiconductors. Extrinsic means which are non-pure. So there can be again two cases. One will be p type and another will be n type. So for n type, that is easiest. N type means you can also switch this. N type means there is high concentration of electrons. What happens is, now this is the proper picture: valence band, conduction band. So as we remember, all the valence band, this is considered as very small thickness. So a particular energy level is considered as EV. This is EC. Now, and this is what we have learnt last time: Fermi energy of intrinsic semiconductor, pure semiconductor. For n type, we also call, so in the n type there are more number of electrons. Electrons means they can donate the charge, and their energy, collective energy, is shown as this: E donor, and that is just below the conduction band, because those are high energy. So those are shown just below the conduction band. Important point: these are individual charges, so that's why they don't constitute a band. When you have the band where there are many number of particles or many number of electrons, and most importantly there is slightly difference in them, here those are extremely in less number. So but this is what the donor energy is shown as. Now because of this donor energy, this is intrinsic semiconductor energy, this is donor energy level. What happens is, because of existence of these impurities added to the original or pure semiconductor, intrinsic semiconductor, this Fermi energy shifts towards upside. This is important point. So you can just imagine this way: there is pure semiconductor, the Fermi energy is this. When you add some impurity, like for example you have 1000 intrinsic semiconductor atoms, and you just add 10 donor semiconductor electrons, because of those 10, this energy, overall the Fermi energy, now you may remember what we talked about as a weighted mean or center of gravity. Center of gravity of this and this moves up, and that goes just even above the E donor, So you will have to remember these diagrams. So right now we are checking for n type. Whatever I have discussed, please start writing. I have only now 5 minutes. Please start writing. First of all, pause this video, draw this diagram. Now just give the title: position of Fermi level. First, n type. N type semiconductor has more conduction electrons than holes. Full stop. This moves the center of gravity up. So Fermi level is above the middle of the forbidden band. Okay, above. So in this figure shows energy levels of donor as isolated circles, these isolated circles, and not as a band. EF intrinsic, EFIN represents the position of Fermi level in intrinsic semiconductor. This is what we just refreshed, whatever we have learnt last time. Now important part: in case of extrinsic semiconductor, at 0 degree Kelvin, all the donor levels are occupied. and there are no electrons in the conduction band. Since probability of E equal to 1, you may remember from last time, P of E equal to 1 up to donor level. Till here there is good probability that that electron will be occupied, that level will be occupied by an electron, and P of E equal to 0 at the conduction band. So above this particular level, conduction band, there are no electrons in the conduction band is completely empty. So, and P of E equal to 0 at the conduction band. Fermi level EF is at in between these two. So effectively what you will get, ED हा जो डोनर आहे तो याच्या आणि कंडक्शन याच्या मध्ये तुमची जी EF, त्याला आणि पुढे नाव द्या वाटलं तर की एन टाइप. सो इफेक्टिवली ती जी फर्मी एनर्जी आहे दॅट इज गोइंग टू बी समवेअर हियर. अरे यार काय बंद पडलं. ओके ठीक आहे, इट इज गोइंग टू बी समवेअर हियर EN टाइप. सो ही जी आहे ही फर्मी एनर्जी अशा पद्धतीने शिफ्ट झालेली असेल. दिस इज व्हॉट दिस टॉपिक इज. द सिमिलर वे इट इज गोइंग टू बी चेंज्ड फॉर P टाइप. सो P टाईपसाठी काय होणार आहे, आय हॅव टू जस्ट एडिट दिस. ऑफकोर्स हा वरचा सगळा पार्ट जाईल, ही एनर्जी तशीच असणार आहे. आय विल जस्ट पॉज. सो इन अनालॉगस टू द प्रिव्हियस थिंग, P टाईपमध्ये देर P म्हणजे पॉझिटिव्ह म्हणजे ॲक्सेप्टर असणार आहेत, होल असणार आहेत, त्यामुळे इथे नेगेटिव्ह सिम्बॉलने यांची एनर्जी दाखवलेली आहे. सो ई ॲक्सेप्टर ही जस्ट अबाव द व्हॅलन्स बँड लेवल. त्यांची जी एनर्जी आहे ती का असते, कशी असते, अगेन हा आत्ताचा तुमच्या ॲब्सोल्युटली सिलेबसचा पार्ट नाही आहे. ही इथे एवढी असते, एवढं तुम्ही लक्षात ठेवा. इंट्रिन्सिकमध्ये जेव्हा ॲक्सेप्टर एक्स्ट्रा इलेक्ट्रॉन्स ॲड होतात, ॲक्सेप्टर्स म्हणजे असे काही ॲटम्स ज्यांच्यामध्ये होल्स आहेत असे जेव्हा ॲड केले जातात, 1000 या ॲटममध्ये 10 जर हे ॲड झाले तर त्यामुळे इफेक्टिवली ओव्हरऑल जी 1010 ॲटमची जी काय एनर्जी फर्मी एनर्जी लेवल आहे ती खालती शिफ्ट होते आणि तिची लोकेशन ही साधारण इथे असते. सो हे प्लीज तुम्ही लिहून घ्या. सो अगेन ड्रॉ दिस डायग्राम आणि स्टार्ट रायटिंग. Subtitle Position of Fermi Level in P type. Okay, P type semiconductor concentration of holes is greater than that of electrons. Hence, center of gravity moves down, so Fermi level is below the middle of forbidden gap. So, खालच्यापेक्षा E acceptor